Tireless research and unwavering passion are trademarks of those at the forefront of discovery. The Lone Star State is home to many of the best and brightest professionals who have dedicated themselves to innovation at the highest level. Tonight, the Academy of Medicine, Engineering, and Science of Texas honors 4 such forward-thinking innovators with the 2012 Edith and Peter O'Donnell Awards. Philip Scherer, Medicine.
Wow, I can never get enough of those. They look so beautiful with these lipid droplets and everything.
Dr. Philip Scherer still gets excited when he sees intriguing cells. But nothing thrilled him more than discovering a protein produced by fat cells called adiponectin. A discovery that has led to new avenues in the investigation of obesity and diabetes.
We see that high adiponectin generally is a sign of good metabolic health. Low adiponectin synonymous with inflammation, insulin resistance, and other troublesome aspects of metabolism.
At UT Southwestern's Touchstone Diabetes Center, Scherer has made a discovery that has turned most of our assumptions about fat tissue upside down. Fat cells make many molecules that can cause inflammation and insulin resistance. However, one of the fat-derived hormones he has identified, called adiponectin, actually serves as a potent defense mechanism against type 2 diabetes.
We don't want to endorse obesity. However, it is protective. That is our one cell type that is specialized in the storage of these triglycerides. And as such, it's really that one tissue that we want to keep happy in the context of metabolic health. They clearly seem to have a difference at the level of the free fatty acids as well.
Scherer also discovered certain cells in fat tissue aggressively support the growth of cancerous tumors. Inhibiting these fat-derived growth factors could help in treating the disease.
We are now trying one by one to determine what are the most critical components that the adipocyte produces that actually offer an environment that makes these tumor cells more at ease and then allows them to actually proliferate and eventually metastasize.
Scherer started his career in his home country of Switzerland. His work eventually led him to the United States and now to UT Southwestern. His research earned him the Lilly Award for Outstanding Scientific Achievement from the American Diabetes Association.
I was very, very impressed by his work ethic, his ability to organize talented young people to work in his lab.
250 publications and more than 20,000 citations in scientific journals are proof that Scherer's work is getting noticed. He vows to continue his work with adiponectin and further investigate how manipulating adipose tissue can overcome type 1 and type 2 diabetes, ultimately allowing us to live better and longer.
Obviously, we have an obesity epidemic, so we will really need to know what to do about the metabolic dysfunctional adipose tissue, which is pretty much at the core of all of these disease phenomena that we are very familiar with.
Michael Deem, Engineering. Mathematical equations are nothing new to Dr. Michael Deem. But this one is fighting an illness that affects millions of people every year. A bioengineer at Rice University in Houston, Michael has devised an intricate equation that can predict which flu strains will be dominant in the coming season. Quickly identifying these strains can lead to stronger and more effective vaccines.
We can detect that months to years in advance of when it really permeates through the population. So we can do somewhat better than the current World Health Organization approach.
It often takes several months of testing to find the dominant flu strain. But by using Michael's method of assigning numerical scores to virus mutations, finding the dominant strain is much faster.
And this is actually an example of a new H3N2 strain that came out in 2009. And we found it about 4 months before the WHO and CDC were able to find it.
Michael is working with the Centers for Disease Control and the World Health Organization in identifying these emerging strains much sooner than ever before. Early detection can ultimately save lives.
The vaccine we'll get in October, they design it in February or so. So we want to predict in February what are the strains that will be circulating around and might infect us in October.
The mathematics that Michael has developed to describe evolution of structure is being described by some as a new law of biology.
We want to define Newton's laws for biology. We want to define an example of F equals ma for biology.
Michael's equation describes the relationship between a system's structural complexity, or modularity, m prime, and its ability to thrive, r, in the face of environmental stress, pe.
It struck a lot of people as a really wacky idea, right? Are there fundamental laws of biology? Is there a Newton's laws or a Maxwell's laws? There's some underlying principles in that they could be mathematized. That was really the issue.
Michael is also testing whether his proposed law of biology can predict when critically ill patients are about to take a turn for the worse. In a preliminary study, he and other researchers identified a subtle signal within EKG data that can predict when a heart attack is likely to happen. Michael plans to use this technique to create software for patient-specific health forecasts.
He had a fundamental insight that forces cause a mathematically quantifiable change in the organization of the system. So I think Michael has made a fantastic, a wonderful contribution to science.
These are really new areas, and this is something that I think Rice really is encouraging these days, is this interaction between what we can do here at Rice and what people over in the medical center can do, and then what can we do when we work together.
Carl Gephardt, science.
We are unable to model what is going on inside of a black hole. It's a location where all of our equations are breaking down.
At the University of Texas at Austin, Dr. Carl Gephardt is shedding new light on the formation of galaxies. His research shows that black holes play a vital role in how galaxies are formed.
In something like astronomy, where there's lots of messy physics, when you make a galaxy, there's stars that are forming all over the place, there are jets being shot out of the black hole in the middle of the galaxy. Once you get a correlation that's so tight, it means something fundamental about how you make the galaxy and how that is related to the black hole mass.
Carl has uncovered a strong correlation between the mass of a black hole and the formation of a galaxy, forcing scientists to rethink how galaxies evolve. Carl has also made the first ever discovery of an intermediate-sized black hole, an assertion initially met with controversy since only so-called large and small black holes were thought to have existed. But further research confirmed his finding and quieted skeptics.
This is one of the galaxies where I saw a spatial offset between the two AGN emission components.
In velocity.
And so spatially, there's like a thing here.
Carl's latest discoveries are literally his biggest. In early 2011, he measured a black hole 7 billion times larger than the Sun, the largest black hole ever recorded. Just months later, he and a colleague measured 2 black holes, each with about 10 billion times the mass of the Sun.
The mass of these very large black holes has very significant implications. It sets the scale for how large a galaxy you can actually build and how large a black hole you can actually build.
Carl isn't resting on his laurels. As a project scientist of the Hobby-Everly Telescope Dark Energy Experiment, he and his team will try to determine why the universe is expanding at such a high rate. They'll do that by mapping the positions and velocities of over 1 million galaxies.
He has a real knack of finding where the forefront is and working there, and I'm completely confident he will do that. He has gone from sort of one clever idea to another throughout the course of his career, so there's little doubt in my mind that he will find something else to do after this HETDEX thing runs its course.
Is that going to be on each detector then?
Yeah, so each detector.
Carl plans to continue to try and solve the mysteries that surround black holes and their place in our universe.
That's one of the great attractions for me as a scientist and for the public as well. You have this great mystery. We just don't know, and that's why it's so attractive.
Ted Moise, Technology Innovation. Ted Moise has spent the past 14 years of his career focused on a major breakthrough in memory technology.
You generate the travelers?
Yes.
Very good.
Ted and his team at Texas Instruments have developed an ultra-low power memory technology that will never run out. Ferroelectric Random Access Memory, or FRAM, is faster, holds more data, and runs on less power than similar embedded memory on the market.
We're not talking about incremental innovation. This is like a 10x to 100x improvement over the state of the art.
So what we've done is to figure out a completely different method for storing non-volatile data on a chip using a bistable polarization of a low symmetry class of crystals called ferroelectrics. And we can create a technology where you can store memory within digital circuits using very low voltage and low power.
FRAM technology has the potential to help everyday products like smartphones and tablets store more data while using less battery. More importantly, FRAM can do the same for life-saving medical implant devices like glucose meters and pacemakers.
This memory, is because of the way it's built, is very insensitive to radiation. So if you put it through an X-ray machine or other types of medical diagnostics, it's really not affected. And so it's a very good match for medical applications.
But overcoming the obstacles common in the semiconductor industry wasn't easy. Securing funding, proving performance, and addressing liability issues can often kill a project. Ted wasn't going to let that happen.
I can remember at least 4 instances in the last 10 years that I've been in meetings with Ted where he was trying to make the case for why we should keep going.
Every time a key meeting came up, every time we were down to our last bit of budget, our last silicon in the lab, we would get some very good result. And I'd be able to go into a meeting and say, look folks, this is the latest yield, this is the reliability, this is what the customer wants, it's all looking pretty promising.
Ted's persistence has paid off. FRAM was introduced in 2007 and is now being used in products developed by companies like Hewlett-Packard, Canon, and BMW. Soon, FRAM technology will find its way in medical applications throughout the world.
You don't come across innovators, and I differentiate that from inventors very often. And Ted is clearly one who is an innovator.
We were convinced that we could make this into something very, very significant. It's a tremendous satisfaction to be recognized this way. It's a great reflection, I think, not only of my efforts, but of the efforts of the whole team here at TI.
Congratulations to all of this year's recipients of the Edith and Peter O'Donnell Awards.